start of the year, but this is the final presentation of Fall 25-26. Welcome to the presentation of TaksiKıbrıs. The brilliant engineers here with me today are Cevdet, who's our database developer, Sudenaz, who's our UI/UX designer, Abdelrahman, Siddig, who is our backend developer, and I am the front-end developer. We have an agenda for you today. We're going to discuss 5 key things. We're going to talk about the problem, we're going to talk about the solution, we're going to discuss the implementation details and testing, and then give you a live demo of our application on the web. But before I talk about all of these things, I want to start with a story. Now this story happens not too long ago actually. It's been cold lately, it's been rainy lately, and I promised a friend of mine that I would help him practice for an exam. But something came up as I was going to see him. It's late evening, it's cold, it's rainy, and it started raining in the middle, so I didn't know if I should turn back. And I see a taxi, and it's great, because I need a taxi. And so I start signaling to him any way I know how, stop for me! And he doesn't. He puts his hand up, and he drives past me. And I see that man twice that day, sadly. And I end up going to my friend's house and walking, and I wait when I get there. But this experience isn't unique. And taxis aren't just a bailout for poor time management. They're a legitimate mode of transport, and yet, in a country that is calling out for it, passengers struggle to find taxis manually. And there is unpredictable pricing for taxi services, leaving people like me that day with inconvenient and unreliable transport options. And even then, even with all of these problems, there is still no dominant taxi service in North Cyprus, and our team sought to find out why. Why are there no taxis in North Cyprus? We came up with 4 answers. The first is economics, the second is culture, the third is language, and the fourth is the chicken-egg problem, otherwise known as inertia. And what that means is, you have the taxi app, you want to have taxi drivers, and you want to have passengers. Taxi drivers can only be incentivized to join an application if there are passengers, but passengers are not incentivized to join an app if there are no drivers. So who joins first? And then there's language. This is a multilingual region. People from all nations come here. An app that successfully solves the problem has to have support for people speaking English, and people speaking Turkish, and potentially even people speaking Arabic. And then there is culture, in that for a taxi app to survive in this environment, it has to take into account the status quo of how payments are made. Some taxi drivers may not prefer card, they may prefer cash, they may not want to be on something that's going to take money from them. There's even whispers that local taxi drivers have been unwilling to share revenue with or pay for a taxi app. And so, after this, all of these problems led us to even more questions. How do you design a taxi app for Northern Cyprus? Are we going to add multilingual support? How are we going to do that? How are we going to handle user adoption? How are we going to handle payments? And all of these questions led us to TaksiKıbrıs, the student-first taxi app for North Cyprus. Now, TaksiKıbrıs is not one app. It is an ecosystem. It is 3 different applications with one purpose. A passenger app, a driver app, and an admin web panel, all synchronized with a single backend and a single database instance that can scale horizontally or vertically in the cloud. And it's designed this way because it's meant to serve 3 different kinds of people. The first are passengers, whose main abilities are what you'd expect of a taxi app. There is to book rides, cancel rides, and a vehicle type, view ride history. The second are drivers, who have, again, the functionalities you might expect from a taxi app. They're able to accept rides, set their availability, register vehicles, view their earnings, and so on and so on. But there's something different about TaksiKıbrıs, which is built specifically for this environment. And there's this feature that we call friends. On TaksiKıbrıs, drivers and riders are students. They can connect in the app and become friends after a ride. This creates trust and repeat usage, and it drives adoption by the very people who need the service. Now you might have noticed at this point I said we have 3 user groups, but I've only mentioned 2 so far, because the last user group are the admin users. That's us. That's the people behind the curtain who can see everything about the system. We have a dashboard where we can configure system level settings, we can link drivers and passengers, and we can view analytics about our system and generate reports. But this is the big scale. And Baran has the details. Over to you, Baran.
I will be talking about technical decisions we have made throughout the development of the TaksiKıbrıs and implementation steps we have applied. We will start with a high-level system architecture. While developing an app like this, you came across several problems, and we have decided to solve this in a modularized system. We have 5 modules, as you can see. All the request flows start from the driver app, or passenger app, or the web admin dashboard. And it goes through a gateway, it starts with an load balancer, and then goes into the backend service, we choose it Express, and then authorizes every single request being made using Cyprus authentication and JWT tokens. And after that, our backend has access to 8 different microservices. And all these microservices can use either the Cyprus database or the external APIs which we have to use, or the custom specifications for specific requirements for our system, as well as like SMS gateway, location entry for maps, exposure notifications, etc. But how do we keep all our data consistent and integrated? How do we protect the integrity? So as you can see, we have a giant ER diagram for our database, but it consists of 3 core tables: relationships and some service supporting tables. But first core table is the passenger. The passenger can create bookings, track rides in real time, save locations, rate drivers, manage members, contacts, and friends. And these are connected for pieces of the corresponding tables in order to keep all the data and the integrity consistent. And the second one is the driver. The driver accepts or rejects rides, update availability status, register vehicles, track earnings, navigate trips, and rate passengers. And again, it is connected to the personal table. And the trip table connects everything at the end. The flow starts with the booking, and then it goes to trip management, and then with the payment, all the flow ends. And all of these are happening with real-time location tracking, as well as fare calculation and mutual ratings for interconnected ratings. So in order to achieve all these, we have to use some libraries, including React Native for cross-platform development, and Location IQ for location services, web services, which we see on the UIs, and I-18 for multilingual support, which is crucial in Cyprus because it is used by English and Turkish is used interchangeably mostly, and Node.js and Express.js for the server framework, and Supabase for our database interactions like real-time database authentication, and everything is handled in Supabase, and Expo handles the notifications and dependency management. But why this architecture means? The first of them being scalability. As I said, we have 8 different microservices, so every microservice can have some peak hours. Instead of scaling all the system, which would cost insane amounts of money, we scale each microservice independently, if needed. Real-time by design, and cross-platform, which everyone can use in their different types of devices, and while achieving all these, keeping everything secure. And this makes our production ready. But what do the user need in order to run and start using this app? Well, we keep the requirements minimal. The location access is required for map services and location services. And it works best with the stable internet because we need some real-time data update. And phone number is optional, but it is suggested to add because if the driver wants to contact with the passenger, they will need it. So it is optional, or we can use the in-app chat for this, but it is suggested to add. But how does this app work? This is the most crucial question. So I'm handing it to the Abdul for answering the question.
Hello everyone. In this section I will explain how we tested TaksiKıbrıs to make sure that the system is reliable, functional, and ready for real use. Our testing focused on both the front-end mobile app and the back-end system. Our overall testing approach was based on agile workflow. What does that mean? Agile workflow means that we kept testing the app continuously while developing the app and not waiting until the end to test it. we verified all functional requirements such as logging in, booking a ride, accepting a trip, and non-functional requirements such as scalability and performance. We focused heavily on system integration, making sure that the mobile app, the server, and the database all work together at the same time. In the front-end UI testing, we tested screen navigation and user input validation to ensure that the user can move smoothly and have an easy interaction with the app. We also checked that the app works properly in multiple languages. We have 2 languages, Turkish and English, and we made sure every translation was made correctly and the app doesn't have any translation mistakes. We also checked for the responsive design layout by testing it using different devices that have different screen sizes, and it worked perfectly. For backing testing, it was performed using Postman and Express Query UI to validate REST API endpoints. We tested core backend functionalities such as authentication, booking, and trip logic. After fixing detected issues, regression testing was performed to ensure that existing functionalities were not affected. And we also ensured that automated tests for core backend and front-end logic are working correctly. So now we're going to present the passenger app and the driver app. Here we have the passenger app and the driver app. I'm going to start with the passenger app. In the passenger app, I'm going to start with the profile page. The profile page shows the user's rating. It shows the total rides the user did and how many kilometers did the user travel using TaxiKıbrıs. The user can also edit their personal information. They can add an emergency contact if needed. They can change between languages, as you can see here. Everything is translated correctly. The user can also choose their preferred vehicle between large and standard. They can also add, save their favorite locations such as home, work, any destination, just to make it easier for the user to interact with that. Like as you can see on the home page, there's quick destinations which is saved from the user. In the front page, this shows the drivers that the user added and they can contact with each other. It also shows the past drivers that the user has been with, and the user can add the taxi drivers on this page. Moving to the history page, this page shows all of the previous ride history. It shows all of the details about every ride the user had. It shows the date, time, the payment, the distance, the location, and the driver. Last but not least, the home page. And in this page, it shows the quick destination, it shows the trips, the recent trips, and user can book a trip from here. Here I'm going to simulate trip booking with Baran. For example, let's say confirm destination. I'm going to choose which preferred vehicle I want. Now we're looking for a driver to accept our trip. I'm Baran.
So what the driver sees in their own app is that the ride request being sent to them is like a pool which many drivers can see. And specifically, this driver can accept or decline the ride request. If they accept to get the driver yes, and the trip starts. As you can see, the real-time update has updated the passenger app, and the driver now can proceed away to the location. When the driver is going, they click at the start navigation and the update that is being made on the database. And then they arrive at the pickup, start to trip, the vehicle start to go to place, and then the trip ends. And when the trip ends, you can see that the trip is completed, and the driver can wait the passenger, and plus the passenger can wait the driver as well. Well, once this is done, the driver app also searches for several other features, including the earnings based on a time period, how much earning do you have, and also some statistics. Some stats about your recent price and your customer rating, acceptance rate, cancellation rate, and all the other stuff that is being used for the algorithm on the next side. And also, the driver can update their profile, and they can update their vehicle information, and they can also change the language as well as quality support. And this wraps up the driver app. And now, what happens on the backside? How do we actually monitor what's happening? This happens in the admin dashboard. And now, Sudenaz will talk about the admin dashboard.
So, you've seen so far the purpose behind TaksiKıbrıs. You have seen how we built it, how we tested it, how our passengers request rides and drivers accept them. Now, who's watching all of this? Who ensures the system runs, pricing stays fair, and the quality remains high? That's the admin dashboard, and this is the app's control tower. Now I'm going to do a full demo of the dashboard. Okay. In the first glance, you see numbers. What these numbers mean? 44 total rides, 2 drivers, 4 students, and approximately chart everything, and the system handles pretty much the complexity in between this ecosystem. TaksiKıbrıs isn't just a graduation project, it's a working answer to a real problem right here, right now in the country that we live in, and in a market where global solutions haven't reached yet. The foundation is here, the architecture scales, the code is absolutely production ready. Northern Cyprus needed this, and we have built it. Thank you. We are ready for your questions.
We will make that system for you.
Why really? Because there are 1 billion more than 1.5 billion there. So how does it scale?
I would say that this specific solution has been made specifically for Cyprus, but I think that the architecture itself is as generic as a taxi app can be, and so it can be adapted to different environments, different colors, and different themes that would be needed for a different setting.
Actually, we have many applications like this in Turkey, especially for example, we have many for this students. It's global actually. If you enter the Push Yapamanusta, you can easily find the road, but you will not find taxis there. You can see the route, but you cannot see the taxis. The most important thing I want to understand from your project is, for example, here you are asking a taxi, I'm a customer and I'm asking a taxi. Am I right?
Yeah.
Then one of the taxi driver accepts me, and then I'm starting to wait. Is there any information that tells me after how many times the driver will come to my location or not?
There is information that tells you
This is
how much time.
important actually for the customers.
However,
You haven't got this.
however, we do show you the live location of the driver, so you can see the driver's location is there.
I also would like to ask that. Whenever I want to ask a taxi, can I see all the taxis available around? And can I select the one which is very close to me? No.
No.
Only
But I think that's a good
only
idea.
drivers can accept me, but I want to see the time that will come to me.
I think that's a good idea. It's a good suggestion. We don't have it, but it can be added.
Yeah, that's important. And also the route.
Well,
Are you showing the customers the route that they will follow?
yes.
I can see it here. Can you show us a demo of that one? For example, from publish to computer engineering. Actually, if you check the Uber Turkey, you can see all routes, all taxis, in how many minutes it will reach to you. These are very important.
This feature is actually available on mobile. We have limited availability to those in the application on web. So we actually did put a warning here that says welcome to you for the directory to mobile. So the application is meant to be used as a mobile application, but we demonstrated it on web so we can present it.
So, actually these modules are important. The time that the driver will come to me, can I see all the other taxis, and is it possible to let customer to select the taxi? Here only taxi drivers access the customers.
We have a workaround for selection. We have the friends system. So if you get friends with like a previous past driver which you have used before, then you want to ride with them again, so you can select them and specifically call them to your location. Then we have like a workaround like that, but not specific selection of like all the pool for like driver pools.
Okay, so in that system we have to use GPS regularly because we have to know the location of each taxi driver and so on.
I think that's already implemented. So we already know the location. Yeah.
It's fine.
I mean, Mr. Baran, I asked about how do you run small water accounts?
How do you prevent that one?
From water accounts registered, like, for example, like water accounts here,
So we are using like the native security system of the Sudenaz authentication. The Sudenaz handles it like native. So what it does is like you know some there are some list of both accounts and other stuff like temporary mails, some more like both accounts, spam accounts, and all temporary purpose of database. So the Sudenaz authentication system both checks it and also checks the patterns, like trying again and again all our load balancers. There's like a round robin system, checking all the requests one by one. If all like several requests are being made from the same origin, time and time again, time after time, this is being blocked natively from our system. But if they somehow pass our system and go into the Sudenaz authentication, they should pass another security layer, which is provided by big companies, and we trust in them.
That was selecting myself.
Yeah, we to kind of add to the
Use a fake thing or taxi somewhere.
For identity verification.
Yes.
So for identity verification, we have like a system for the drivers. They should apply or register. But for the passengers, as well as like as soon as they start with the registration flow and they create the account, after that they are able to call the taxi. So we don't have any extra savings there for that. But as well as having this, like as simple as possible. If the taxi, like taxi, first we contact the passenger before going, like it doesn't like the order. So we suggest them to like get in contact, do not go without contact. As you can see, like we have like a status of the trip. So it starts from like the first step is start the navigation. Like you can skip like the whole flow and just cancel the ride. You cannot reach out to them. So instead of trying to block out accounts from creating like fake identified, we are trying to block out the most crucial part, which is being called the taxi. Instead of they cannot call the taxi, that's how they flow goes. But we suggest them.
Next one I asked, on the admin section, admin part of the group, you actually have like the administrator have the driver's documents that one by one they are being looked at and they are being confirmed. Is this person real? Has they opened an account before? Like this is like administrator is responsible for that. So that's another secret.
I have a small question. Have you or did you do any survey with taxi drivers? Do they want this system or do they like the system? Or did you do any survey?
Yes, we did do a survey with taxi drivers, and we could confirm that the taxi drivers were not very happy about the taxi app in Cyprus.
Okay, thank you very much.
Thank you.